Welcome to the Crazy Head Chemist. So here we go. Empirical formula calculations. The second set, but overall we're talking about stoichiometry still. So here we go. Bam! So we're going to calculate the empirical formula of a compound containing 43.7% phosphorus, the remainder oxygen. So I know I have phosphorus and oxygen. I need to solve for the simplest whole number mole ratios. That will be the X and the Y. So I know that my whole entire compound has 100% because it's only phosphorus, it's only oxygen. I know that 43.7% of it is phosphorus. How much of it is oxygen? Well, 100 minus the 43.7, that gives me my percent of oxygen. So, simplest whole number mole ratio. That's what I'm looking for. I have percentages. I'm going to assume 100%. Therefore, I'm going to assume 100 grams. So now I have 43.7 grams of phosphorus and 56.3 grams of oxygen. I'm going to convert the 43.7 grams of phosphorus into moles of phosphorus and the 56.3 grams of oxygen and convert that into moles of oxygen. And here is the first step, converting the phosphorus. This is using the molar mass, of course, and then using the oxygen molar mass. Again, oxygen is not diatomic. That Y is not necessarily a 2, and certainly it's a compound and not an element, a molecular element all by itself that's diatomic. I'm going to do the math on here, and this is what I get. Now I'm going to look at these two numbers. I got the 1.4 and the 3.5. I'm going to look at these two numbers and compare them and ask myself, which of these two numbers is the smallest? The 1.4 is the smallest. So now I'm going to divide both of these numbers by the same number. It's always the smallest number. So I'm going to divide both of them by the smallest number. And when you do this, one of the numbers is always going to be a 1, as is the case here with the phosphorus, because it's the number divided by itself. That's the 1.4, etc., divided by 1.4, etc., and I get that number. So where am I looking for rounding? I'm looking at this 4 for rounding in the 10th position. It happens to be a 4. It's not a 0. I want a 0. Or I want a 1 so I can subtract a 10th. Or I want a 9 so that I can add a 10th. But it's not either one of those. So here's the problem here. I need to figure out what I need to do to multiply this number so that I get a 0, 1, or a 9. So here's the multiplying factor, and here's how you do it. You're going to use the reciprocal of the decimal in the 10th position after you round it. So that number in the 10th position is a 0.494. I'm going to round that to 0.5. So 0.5 is my decimal position. I'm going to take the reciprocal of that, and that would be 2. So I'm going to multiply the 2.494 that's in my calculator times 2. And then I'm going to get a number of which in the 10th position I can round. Now, this is a whole number mole ratio, and I need to maintain the ratio. Currently, the correct ratio is 1 phosphorus for every 2.5 oxygens. So if I multiply the oxygen by 2, I'm going to do the same thing for the phosphorus. I'm going to multiply that by 2. So 2 times 1 is 2. And then the 2.494 times 2 is 4.98. Now here you should see that in the 10th position at the 4.98 with the oxygen, that's either a 1, a 0, or a 9. In this case, it's a 9. So I'm going to add 1 to the preceding digit. That 4.98 is going to become a 5. That's why I'm looking at just the 10th position. I don't care about that 8. Okay? So then I get these following numbers. So how many phosphorus do I have? 2. So I substitute and replace that X with a 2. How many oxygens do I have? 5. So I substitute and replace that Y with a 5, and I get P2O5. Now I'm going to ask you, what is the name of this molecular compound? So again, this has no charge to it. This is a binary non-metal compound, so I have to use prefix naming. So how many phosphorus do you have? 2. What's the prefix for 2? Di. How many oxygens do you have? 5. What's the prefix for 5? Penta. So it's diphosphorus pentaoxide. Hopefully that makes sense for you. Okay? That was another Hopefully awesome video for you. I can't wait. We are almost finished with empirical formula calculations. We have one more to do, the third one in this subset of stoichiometry problems. I love stoichiometry. See you next time.